Hello Honors Chemistry students, this is Mr. Spurk, and this is your Chapter 16, Section 2 notes on concentrations of solutions. So you've heard me talk about concentration before, and you've seen the word molarity before, or molar, when we talk about how strong an acid is or how strong a solution is in the lab. So now we're really going to talk about what exactly does that mean. So concentration is a measure of the amount of solute that is dissolved in a given quantity of solvent. So basically, for example, if we were making salt water, it's going to tell us how much salt is in water. Now, when we talk about concentration, we have dilute solutions, which is a solution that contains a relatively small amount of solute, and a concentrated solution contains large amount of solute. Then we have the term molarity, which we represent in capital M, which again should be familiar to you. In the lab, sometimes you'll see 1.0 molar H2SO4. Molarity is the number of moles of solute dissolved in 1 liter of solution, also known as the molar concentration. So again, we would read this as 1.0 molar sulfuric acid. So to calculate molarity, it's just moles of solute divided by liters of solution. So symbolically, it would be capital M for molar equals moles of solute, so N of solute, divided by volume of the solution. So let's look at an example. So intravenous saline solution, or just an IV, these are often administered to patients in the hospital. One saline solution contains 0.90 grams of sodium chloride in exactly 100 milliliters of solution. What is the molarity of the solution? Okay, so one thing we want to look at is the equation is molar or molarity equals moles of solute divided by volume of solution. And then we want to look at the information we have. We have grams of sodium chloride, and we have milliliter for our solution. So we want to change this to moles, and we want to change this to liter. So before we can do any calculation, let's start there. So hopefully by now you know to go from grams of sodium chloride, we need the molar mass. So we have sodium at 22.99 plus 35.45 for chlorine. Molar mass of 58.44. Gram cancels with gram. We're left with moles. And we have 0.0154 mole. Guess it should be 0.15 mole NaCl. Then let's go ahead and convert the milliliters into liters. 100 milliliters over 1. There are 1,000 milliliters per liter. This is going to be 0.100 liter. Now we can go ahead and solve. So the molarity equals 0.015 mole divided by 0.100 liter. We're going to get an answer of 0.15. And this would come out to moles per liter, but we actually just make it more simple. We say 0.15 molar. So again, we had to convert to moles, so we could divide by liters. Mole per liter is the same as molar. All right, let's look at another one. How many moles of calcium chloride are in 80 mils of 0.50 molar solution? So we're working a little bit backwards here. So instead of solving for molarity, we're solving for moles of solute. So again, our equation would be molarity equals moles divided by volume. but we're solving for moles, so I'm going to rearrange my equation. So moles equals molarity times volume. The molarity is 0.50 molar, or just to show you, I'm going to write it out as moles over liter, times, and I'm going to convert this to liters. And then we see that liter on the top cancels with liter on the bottom. We're left with a unit of mole. 0.5 times 0.08 gives me an answer of 0.04 mole calcium chloride. So again, we can go and solve for molarity, or we can work backwards and figure out how many moles of solute that is. Now we could also take this one step further and convert it to grams, and that would tell us how many grams we would need to add to 80 milliliters of water to make this solution. And that's something we'll talk about here in a little bit. So making dilutions. So both of these solutions, so solution A and B on the right here, contain the same amount of solute, but different amounts of solvent. And you can tell because solution A, you can tell that solution A is more concentrated than solution B based on the color. Solution A is a deeper blue, while B is a more light blue. So color here is usually an indicator of concentration. Solution A has a greater molarity. It has more solute in a small volume. So for example, let's say both of these have 100 moles, or let's say something a little more realistic. 5 moles for A, for what is that, about 80, 0.08 liters. So that would be about a concentration of 5 divided by 0.08. That's a concentration of about 62.5 molar, whereas solution B still has the same amount of solute, but that's at about 350 or 0.350 liters. So that concentration is only 14.3 molar. And you can also tell by looking at the particle diagrams here, look how much more compact those solute particles are than they are here. If you want to think about when we talked about gas laws, it's like decreasing the volume, right? We're making those particles more compact. So diluting a solution reduces the number of moles of solute per volume, but the total number of moles does not change, as we saw here, right? The number of moles is the same. They both have 5, but the number of moles per volume, which is the molarity, does decrease. So the moles of solute before the dilution equals the moles of solute after the dilution. So because of this, we can set up a relationship that says the molarity before times the volume before equals the molarity after times the volume after. And anytime I make a solution for class, I use this equation. So where M1 and V1 again are the concentrations and volumes before the dilution. So again, when I buy sulfuric acid, I usually buy about 6 molar sulfuric acid, but a lot of our labs only need 1 molar. So I use this equation to dilute it down to 1 molar because I don't need you guys getting hurt. So let's look at an example about preparing a solution. So how many milliliters of aqueous 2 molar magnesium sulfate solution must be diluted with water to prepare 100 milliliters of aqueous 0.4 molar MgSO4? So let's read through that again and mark M1, M2, V1, V2. So how many milliliters of this solution? So this is my M1, and it says how many milliliters of it? So that is V1. So I'm looking for V1. And I want to know, I want to make a solution that is 100 milliliters. And I want it to be this concentrated. So M2 and V2. So let's go ahead and set up our relationship. So M1 V1 equals M2 V2. And again, we're trying to solve for how much of this do I need to add to 100 milliliters to make it this dilute. So V1 equals M2 V2 over M1. So M2 is 0.400 molar. V2 is 100 milliliters. And M1 is 2.00 molar. Molar cancels with molar. We're left with a unit of milliliters. So 0.4 times 100 divided by 2 is 20 milliliters of MgSO4. So what that means is, in a beaker, that's not a beaker, that's a box. In a beaker that has 100 milliliters of water, I need to pour in 20 milliliters of 4 molar magnesium sulfate. And when I add that in there and I stir it around, the concentration of this solution will be 0.400. And I'm sorry, that should be 2. So we're just diluting it down, making it weaker. All right, so we can also do things by percent, and we're just going to talk about this. We're not going to solve. So isopropyl alcohol, which is rubbing alcohol that you can buy at the store, is sold as, you'll see on the bottle, 91% isopropyl alcohol. So this is just another method that some people use to show concentration. That would mean that in 100 milliliters of 91% isopropyl alcohol, 91 milliliters is isopropyl alcohol, and 9 milliliters is water. So here's that calculation. Again, we are not going to solve for percent solutions. Another way you're going to see it, especially in industry, is concentration is often expressed as a percent by mass. So here they take the mass of the solute divided by the total mass of the solution. As always, all the information on these slides has been acquired and adapted from Pearson Chemistry, 2012 edition of the textbook, resources CD, and pearsonchem.com. Have a great day.